All right, you 11s. Quiet down. Let's begin. Phones away. Let's begin. I'm going to write up your functions again. Still, there's a bit of a leftover from last time here, so I'm going to write it down again. Let's see what you remember. I've got ax to the power of n. You've got e to the x, log e of x, sine of x, cos of x, tan of x. So again, let's go through the rules. Hamish, what was the rule to find the derivative of the power function ax to the power of n? What's the derivative?
A times n times x to the power of n minus 1.
Very good. dy dx is equal to a times the n times x to the power of n subtract 1. Okay, so whatever the power is, multiplied to the coefficient to the power of whatever it is minus 1. Okay? That's the derivative if it's a power function. So anything to the power of half, power of -1, power of -2. Actually, not -1. Actually, no, it is -1. Yeah. Power of -1, power of -2. You can do with this rule. Let's say that you don't have a polynomial function. Let's say you got an exponential, but remember it has to be a base e. What was the derivative of y equals e to the x, Trent?
E to the x.
E to the x, very good. So you got dy dx, the derivative is e to the x. What about log e of x, Steph? Good, dy dx is 1 on x. What about sine of x, Rachel? Cos of x, very good. dy dx is cos of x. Ben, what about if it's cos of x?
Dy dx equals negative sine.
Very good. dy dx equals negative sine of x. And the last one, let's go with Akita. Derivative of tan of x. Not 1 over sec squared. Good. 1 over cos squared of x, or another way of thinking about it is 1 over cos x all squared, which is dy dx, or you can write that as the second squared. Okay, that's what SEC stands for. These are your 6 rules that you had to learn, and that technically normally takes about a week and a half or so, because each one's a session. Okay, so you think about it, 1, 2, 3, 4, 5, 6, then it's like 1 and a bit. Okay, we would do it per session. So we did that in about 3 sessions instead of doing a whole week. We did it in 3 sessions just to make sure you know the rules. Now I also taught you another 2 rules. So you got power rule, you got the derivative of every single functions that we kind of know. What am I missing? 2 more. Give me one, Seb.
Chain rule.
We had a chain rule. So you needed to know your chain rule. What was the chain rule again, Anna? dy dx is equal to dy du. Good, times du dx. Okay, so chain rule is your bread and butter. It applies to every one of these functions here. The purpose is to make it simpler. That's what it is. It's to make something that wasn't something that you were able to do, but by replacing with a new variable, which we call u, should allow that. That's chain rule. So that's your bread and butter for next year. You're going to be using that over and over and over. Okay? It'll be a mix with other rules too. Now I taught you one more rule. I didn't teach you one of the ones for year 12, but I showed you one more rule, the last one. What was the last lesson's rule, Charlotte? What was the last rule? We've got chain rule, power rule, rule of every function. We're missing one. Can't remember, Akita? Product rule. We had the product rule. Product rule is when you only have the product, means times. If you have a function where you can tell it's 2 things multiplied to each other, so u times v, we have 2 different functions, then we know the derivative, which I'm going to write here. Remember, I gave you a shortcut to memorize, and I wanted you to memorize in this particular way. Will? Okay, what is it? Say again. Good. Now, this is the correct way, and that's how the textbooks will teach you. And I said, I don't want you to memorize this way because next year, when you do the quotient rule, it's easy to confuse the two. So how I want you to memorize it, because plus doesn't actually matter, but when you subtract it does matter. I actually want you to memorize it as VU dash plus UV dash. Okay, I know it feels like, well, why should I do it that way when it was U dot V? It feels natural to say UV dash, right? But this will help you remember quotient rule. So for those who are interested in the quotient rule, which I'll write down here, f of x, when it's u divided by v, then the derivative is equal to vu dash minus uv dash over v squared. That's for next year, okay? But you see why a lot of students in year 12, at the time when particle was a problem, that was about 2012 and 2013, this rule came up more often, okay? Because most students were used to doing uv dash plus vu dash. So when we started doing quotient rule, students were getting that mixed up. Because it does matter whether VU dash subtract UV dash, which one comes first. When you subtract, it does matter. When you add, it doesn't matter, right? That's why a lot of students make that mistake. So what I'm trying to teach you is not to make that mistake by memorizing VU dash plus for product, VU dash minus for quotient. That's the only difference, and it helps you remember that. Okay? So that's what I want you to memorize rather than UV dash, because that's how your textbook will show it. Okay? All right, so this summarizes all the rules, but let's not forget the very beginnings of everything. What was the very first thing I taught when we came to calculus?
It's just the gradient of the straight of a tangent line at 1 point.
Good. Gradient of a tangent line at 1 point. Don't forget that all of this only allows you to find the gradient of a straight line at 1 point, not 2 points, where we always found gradient with 2 points, now it's only 1 point. This is the purpose of calculus, okay? And the very first thing I taught you was called, what was this thing called again? Anyway, starting with F. It's the first something. First principles. Okay, so this whole thing, all of these rules would not have came about unless they had first principles. Okay, so first principles again, it was just your derivative, so f dash of x is equal to the limit h approaches 0, f of x plus h minus f of x over h. Okay? That was the first principle. It's the most tedious way to find the derivative of every function. Technically, if you want to know where all the rules come from, some of it all back in here, and if you simplify it down, that's how you get the rules. Okay, so if you went onto YouTube and look at the proof for each one of these rules, they all start off with this. That's why they call it the first principles. Okay, but because we know that takes too long, we're now memorizing all this. So that's why I'm saying your job is not to prove all these rules. Your job is just to understand what is the purpose and the how to. Okay? Now that you've got all that, today's lesson is applying it so that you could find the tangent and the normal. So if you know how to find the gradient, then the question is, well, how do you find the equation of the line? Okay, so if you know the gradient of the line, you know the slope of the line, then you should be able to tell me what the equation of the line is. Okay, so we're going to do a couple of things to get used to the idea, and it's very simple. It's back to year 9. The hardest work was here. The hardest work is being able to differentiate. After that, the meaning behind it is year 9 maths. Everything after that is year 9 math. Parallel lines, perpendicular lines, intersection of two lines, they're all year 9 mathematics. And that's what chapter 18 was about. Okay, so here we go. First one of exercise 18A. We said that a tangent line is when it touches the curve at 1 point. Okay? When the straight line touches the curve at 1 point, it obviously has a straight line, which we then call it y equals mx plus c. We know that m stands for the gradient of the line. We know that c tells you the y-intercept. Now, let's take this as an example. Y equals x squared is your function, is your curve, right? If I were to draw a tangent line, okay, a tangent line could be anywhere. I could have a point here, and I draw a tangent line there. I could have a point here, and I draw a tangent line there. Both of those have different equations. Because they're both different straight line equations. That's one straight line equation. That's another one. Okay? When you find the derivative, it just helps you to find the gradient. of that line. But you need to know at what point. You need to know where am I looking for? Which tangent line am I looking for? Okay, so let's do an example. Let's say I wanted to know at x equals 1, so right at this point, there's going to be a tangent line that crosses there and it's y equals mx plus c. I just want to know that line at x equals 1 where it touches, that tangent line that touches the point when x equals 1, that point, I want to know the gradient of that line. I want to know m. Okay? So that goes back to our purpose. Our purpose over there was the gradient of a tangent line at one point. That's exactly what we have here. At x equals 1, I want to know the gradient. Now how do you find gradient? This is the how. Okay, that was the theory. This is the how. So how, well, what kind of function do I have? I don't have an exponential, I don't have log, I don't have sine. I have a power function. Okay? And we know that every time we find the derivative, it is to find the gradient. That's what we're doing. So, derivative of y equals x squared, what is that? Can I please have, let's go Lauren, what's the derivative of y equals x squared? What's dy dx of this? What's the derivative? Not sure, using this rule here. So it's a power function, you've got a, you've got n. What's my a and n over there? 2x, that's the answer. Okay, because a is currently 1, so drop down the power, so 2 times 1, times x to the power 2 minus 1, there you go, so 2x. Now, 2x doesn't tell me the gradient because I don't know where. I didn't actually say where in this particular equation here, but I did say where I want it, over here. I said I want it at x equals 1. So how do you find the gradient? Well, you found the gradient function. So at x equals 1, apparently if you sub it in here, this will tell you the gradient. So don't forget, this derivative tells you the gradient. So if I sub 1 in, what would the gradient be? What would the gradient be if I sub 1 into that point? 2. Okay, because if I sub at x equals 1, I sub it in here, then m, or dy dx, is equal to 2 times 1, which is 2. So what does that mean? It just tells you the gradient is 2. So I got y equals 2x plus c. Okay? But I don't know what c is. C is the y-intercept. This line here, I don't know where it crosses. Now back in year 9, if you have a gradient, what else do you need to find c? What did you have to do back in year 9 to find c? What do you need? What do they have to give you first? A point. A point. Now you do have a point. You have it when x equals 1. So at that point, x equals 1, how do you find the y value? What's the y value on the curve? Think about it. It's an x squared curve. At x equals 1, what would y be? 1. So I know at this point here, this is 1, 1, because I knew it was 1 squared. 1, 1. And that just happens to be where the tangent line also crosses as well. So the tangent line has 1, 1 on it as well. So why don't you sub it in and solve for c? So if I sub it in, sub 1, 1 into y equals to 2x plus c, you get 1 equals 2 times 1 plus c, 1 equals 2 plus c, so therefore c must equal to 1 minus 2, negative 1. So what is the equation of this tangent line? Very simple, it's just y equals 2x minus 1. And you can do that for any point. I just made up one, I just said when x equals 1. You can do it when x equals 2. You can do it when x equals negative 1. You can do it when x equals 0. But the point is to understand, every time you find the derivative, it is to find the gradient of the tangent line at one point. And that's how I illustrated it. If you can keep that in your mind, don't forget the purpose, then all this will make sense. All of this is just to find the gradient. The rest is year 9 maths. Okay, so from there, I can even ask you to find the perpendicular line. See, back in year 9, how do you find perpendicular lines again? What's the one property you needed to know? We did at the start of this year as well. Something about the gradients, yes? Good. Remember, the gradients, for them to be perpendicular, gradient of the lines, gradient m1 times m2 equals 2. Oh, wow. Yeah. Sorry, on my screen it looks clean.
You're changing methods.
Yeah. All right, here we go. m1 times m2 equals -1. Now, if you know the tangent line is y equals to 2x minus 1, what's the gradient? Listening? What's the gradient of the perpendicular line? Based on that theory that you know, m1 times m2 has to equal -1. You've got a tangent line, which is this line here, that is 2. Then what should the gradient of the perpendicular line be? Not 2. It says 2 times something. Remember, we've got one of the gradients. We've got 2. It has to be perpendicular. So 2 times something has to equal -1.
One.
-half. 2 times -half, right? So think about it. If you know, I'm going to do it in blue. If this is your 2 times m2, if you want to know the perpendicular line, m2 has to equal to -half. Now, if you know m2, if you know the perpendicular line, which is going to look something like this, whoops. It's going to look something like this. It crosses through there at a 90-degree angle. Then all you have to do now is y equals to -half x plus c. You found out the gradient of the perpendicular line. So how do you find c again? What do you need?
Use the same point.
So you use the same point because they both cross the same point. See, the curve, the blue line, crosses at 1, 1. But it also has a tangent that crosses through 1, 1. And the perpendicular line also crosses through 1, 1. So sub in 1, 1. Sub in 1 and 1, and you'll be able to find C. So here we go. Back to Year 9 maths. Sub 1, 1. 1 equals -half plus C. C equals 2. 3 and 2. And there you go. Normal line, tangent line. You see, so the theory is very quick and easy if you know the hard yards. If you know how to find the derivative, that's it. Okay? And it's the same throughout all functions. Let's do another example, okay? So I'm just giving you the theory so far. Let's do some examples here. Okay, so let's move through.
It makes these all elaborate powerful.
All right, here we go.
From previous years, right?
Yes, from my previous year. Yes. All right, here we go. Let's have a look at this one.
Oh, I like it.
Here we go. Same drill. I want you to have a go. Have a think. You got find the equation of a tangent line. So I want a straight line. I want to know what the straight line is. When it crosses at x equals 2, so at x equals 2, you get a tangent line on this curve. You've got a cubic graph. X cubed plus 2. I want you to find the equation of that line. Remember, the equation of line, you just need the gradient, and you need the y-intercept. That's as simple as it is. Doesn't matter what function I give you. It's always the same method. Okay, so you just need to find the equation of the tangent line, which is y equals mx plus c. Your job is to find m. That's the hardest part. That's the only year 11 part. After that step, it's all year 9. After that, it's all year 9 stuff. So I want you to find the gradient.
Right.
Go. I'll give you 2 minutes. Here we go, 2 minutes. Find the gradient. Use what I just taught you. Find the C value afterwards.
24. Do we have a point? Yeah, we do. That's true.
Very good.
Okay, so y equals 12.
Y will equal
24. Y equals 10. The L's cubed.
Yep.
10, sorry.
So sub in 2. 2 cubed.
So 10 equals 24 plus 6. So no, -14.
Oh, did you find the gradient already?
Yeah.
Yes, you're right.
Very good. So negative 14 y, so y equals 12x minus 14. Wow, linear equations.
Too easy.
I mean, you have to write it down. Come on, do it. Wow. Wow, roasted by friends.
All right, here we go. Let's go through answers. Now again, y equals mx plus c. The hardest part is to find gradient. Listening? To find the gradient, we know that it is the derivative of the curve. This is your curve. Y equals x cubed. So dy dx, using your rules here, let's find the derivative to find m. Let's find the derivative. You've got x cubed plus 2. I want to know the derivative, dy dx. What does that equal to? What's the derivative of x cubed plus 2? Let's go with Simone. What's the derivative? X cubed plus 2. Very good. Derivative of that is 3x squared. What's the derivative of 2? Very good, 0. So, we now know the derivative is 3x squared. But remember, we need to know a point. We need to know a point, and they told us at x equals 2. So looking on the graph, at 2, I've got a tangent line. I want to know what the gradient is. Sub it in. Here we go. At x equals 2, then the derivative equals to 3 times 2 squared, 3 times 4, 12. Don't forget the purpose. What was the derivative tell you? What is 12 telling you? What's 12? It is the gradient. You just found m. Now, y equals 12x plus c. Your job goes back to year 9 now. You got 12, which is the gradient. You did all those derivatives to find the gradient. How do you find c now? What do you do? Find a point. Now I gave you x equals 2, so you need a y coordinate now. You've got an x coordinate, and how do you find a y? What do you do? Into which one? That one or that one? Okay. Wait, this one, because this is y. This is the gradient. This is y. So if x equals 2, 2 cubed, which is? What's 2 cubed? 8. 8 plus 2? 10. Good. So now you've got a point. You've got when x is 2, y is 10, and you're going back to year 9 maths here. You're saying sub, when x equals 2, y equals 10. There you go, 12 times 2 plus c. That's 24 plus c equals 10. And then minus that, so that's negative 14 equals c. So what's my equation? It is y equals to 12x negative 14. And that, right there, is the equation of my tangent line. Yep.
That's what this is all about. 3x squared.
Yep.
You got my reference about the hokey pokey though.
Yeah, I get it.
Bet. That's amazing.
Plus 1.
Is that not?
Oh,
That's what
because
this is
the
all
derivative of 2 is 0. And I'll show you why. See, derivative of 2, if I got y equals 2, another way of writing this is y equals 2 times x to the power of 0. True? X to the power of 0 is 1. 1 times 2 is 2. But if you now use the rule, dy dx, the power of 0, so it's 0 times 2 times x to the power of 0 minus 1. It doesn't matter what this is. 0 times anything.
It's like the piano key.
0.
When fully hooked because it can't get the same everything. Oh, okay, yeah, I understand. It's always that one. Is there, I had a question. Is there derivation exponentials that aren't?
Yes, that I don't know how to do.
Completely complicated. Is that like a uni?
Like, so I kind of intention physical, I have my memory along with me. I don't know how to do it. There would be probably a uni or probably a uni. I reckon they would have to. I don't know how to. I reckon they have to go back to this. So they have to somehow use this to find the derivative. I don't know if there's a shortcut. All right. All right, year 12s. I mean, not year 12, year 11s. Year 12s to be. One more. One last one, because most of your textbook questions, they're using power functions, but I actually want you to get used to all functions. So I made up one question, which should work out. Let's try this one. I want you to do the same thing, See, sometimes you don't get power. It doesn't have to be a power function. It could be any of these functions here. I've got the curve, 3 log e of 2x. I want you to find the tangent line, the equation of the tangent line at x equals half. Same idea. So at x equals half, I want you to tell me what is the equation of the tangent line. Okay, again, 2 minutes. So your goal is to find y equals to mx plus c. That's your goal. Y equals mx plus c. The hardest thing is to find m. The rest is easy. The rest is year 9. Your job is find m. Okay, just m. So don't forget the purpose. If I had to summarize, this is everything you've learnt so far. 17 and 18 and 20. This is calculus, year 11. Let's go. Your job is to find m. Look at the functions. Look at the rules. That's why we've been practicing the rules. Yes, it is a chain rule.
You got to do the law. We do that on this one. No, it doesn't. It has log base 10, but not log base 10.
Yeah, it does. Log base is ln. ln is log natural. Yeah.
What's special about E?
No.
I got 0.
Should be 0.
Y is 0. Yeah.
So when x is half, y should be 0.
Yeah, that's 0 equals 3. Ln plus C. So C to negative 3. Wait, what's the format? I can't read. It's ln. Yeah, I was doing 3 times. 2 times point, wasn't it? Yeah. I was looking at.
You have the 2 there as well.
Oh, it worked.
2 times half.
So what is special about E? Can you explain it to me in 1 minute?
No, because I don't know.
Oh,
Yeah, because it's not in your textbook for me to read.
number though.
It is no. It's Euler's number, hence E.
Isn't it like irrational?
Yes, it is an irrational number, like pi. And he came up with this idea, and that's where I don't know the pattern, but E turned out to be the number. It specifically was designed to find the number where the gradient is equal to the y value, and that's the number. That's why it's such a special thing.
So if you have a log E of x,
Whatever x you sub in, that y value is actually the gradient as well.
the gradient of the tangent.
Yep.
That's why 1 over x, right? Yeah.
It's like mint. That e value, for whatever reason, yeah, e to the x,
So that's why that derivative.
whatever the x value is, doesn't matter if it's 2, then that is the gradient at 2. That's why it's nice. So that means if you drew an e to the x graph, you can read the gradient, like how it grows. That means you can do the inverse for it as well, hence log. But then it makes it harder to do other questions like 2 to the base, like base 2 or something like that. That one I don't know how to do. 3, when you find the derivative? Yep, so you do it separately. So 3, not separately, but like 3 is a constant. It's kind of like,
It's for the x.
so if you put a 2 in front of x squared, then the 2 has always been there. It's 2 times, and then you work on the function.
So you take 3
Yeah, so 3 times the rest of x.
is a half.
It's not half.
So would that mean that the answer would be 3 over 2x?
Yes, you're missing one small thing.
3 divided by 3 times 1 over 2. So 3 divided by
Yes,
5.
so one is correct. So it is 1 of 2 is correct. Times 3 is correct. And this is one more thing.
times by 2.
Because the rule that I gave you was only log e of x, and only log e of x, not 2x. So if you want to...
It was the wrong number.
Oh, no, you were using chain rules. So you want to place what's the derivative of 2x?
We can multiply. I don't know.
So that's just you're missing 3 times 1 over 2x times. They'll be like, wow, I am going to. Because 1 over 2x is I'll write it down. All right, year 11s, quiet down. Quiet down. Here we go. Let's do this problem here. Talk later, Akita. Thank you. Here we go. So, to find the derivative m, which is the gradient, we're going to say dy dx, which is the derivative of this log problem up here. And that's what we've been practicing in the last 2 sessions. So, dy dx, we've got 3 times log. Now the problem is the log has a 2x in there, and the rule I gave you doesn't have 2x. So you have to use a chain rule to make it work. Okay, you're going to replace the 2x with a u. So this is what I'm going to do. I'm going to say this 2x, I'm going to replace that with a new letter, and I call it u. Let u equal to 2x, and that changes my problem from y equals 3 times log e of u. Whoops. Okay, and we can do log e of u because that's the same thing as log e of x. So you found the derivative. It'll be dy dx, dy du is equal to 3 times the derivative log e of u. According to the rule, it should tell you what? What's the derivative log e of u? 1 over u. Okay, because that was derivative log e of x was 1 over x. So if it's log e of u, then it's 1 over u. So here we go. We write 1 over u. But then remember, for chain rule, we said once you find dy du, you need du dx. So you need a derivative of u and an x. But you do have that equation here. See, it was u equals to 2x. Then du dx is the derivative of 2x. Now what's the derivative of 2x? 2, using power rule. Putting them both together, then dy dx is equal to dy du multiplied to du dx. We know that dy du was equal to 3 over u times 2, but u, we said it was 2x. And what you can see is the 2's cancel out. And so then your final answer is 3 over x. Now, the problem with that is you still don't know where. I've just found the gradient formula, but I know that x has to be at half. I want to know what the gradient is when x is half. Now I purposely chose log because it's got a lot of fractions and I wanted you to work with fractions and negatives. Okay, so 3 divided by a half. How many halves in 3? 6. Okay, so that just tells me if I sub x equals half into the equation, sub x equals to half, then dy dx equals to 3 divided by half, which is 6. What does that 6 tell me? Don't forget the purpose. What does the 6 tell me?
The gradient of the cap.
Yeah. And so that just tells me now I know m. M is 6. That was the hardest step. That's the hardest part of year 11 right there for calculus. Yes, for calculus, that was the biggest step. If you get that, that's it, 6x, you're trying to find c. The only way to find c, you need a coordinate. Okay, so here we go. I'm going to rub off the right-hand side here. I'm going to rub this side off. Here we go. So now we have the equation. I'm going to do it in red. We have y equals to 6x plus c. How do you find the coordinate? You have x equals half. How do you find the y value? This is the point. You've got x equals half. How do you find y? What do you do? Sub it in which one? Which equation do you sub in? You got x equals half, you want to find the y value. Sub it in 2? Yeah, the original. Because this is always, the derivative is the gradient, it's the original. And that tells you why. And the reason why I'm emphasizing this is because in year 11, the most common mistakes that I get is subbing in the wrong one. So you do all this and then suddenly you take half and you sub back in here. When you sub half back in here, what do you expect to get? 6. It's just the same thing. And I get students who would write 6x plus 6, and they don't even realize the 6 was exactly the same. Okay, so the half is to find the y value, not the gradient. See, y dx is the gradient. You already found the gradient. Your job is to find the y coordinate. So when x equals half, this says at x equals half, find the y coordinate. So I'm back in here, and this goes back to your log algebraic logs. Now, if I sub half into x, 2 times half, which is 1, anyone remember what log e of 1 is? What's log e of 1? 0. Okay, so remember logs is the opposite of exponential. Another way of thinking about it, I'm going to write it here. Y equals to 3 times log e of 2 times half. That's the same thing as writing 3 times log e of 1. And log e of 1, another way, if you've forgotten how to read logs, remember it's the opposite. It's saying e to the power of what gives you 1, essentially is what it's saying. That's what log e of 1 means. So e to the power of what will give you 1? 0. That's what the power is. Okay, so log allows you to find the power, exponential allows you to find the answer. That's the difference between the two. Okay, so here we go. We now know this is 0, so 3 times 0 is 0. So what does that tell me? Y 0. So now I know that's my coordinate. You got half 0. How do you find C? Sub the coordinate in and do your year 9 maths to find C. So if we sub it all in, we get now 0 is equal to 6 times a half plus C, and then you can see that C equals -3. There we go. That's the equation of my tangent line. Y equals 6x minus 3. It looks like it's a lot of work, but it isn't. That's why in year 11 you do the preliminary, and you're still doing this all the way to year 12. It's the same things over and over and over. So really try not to forget the purpose. Gradient of a tangent line at one point is all calculus is all about. I can't emphasize how important that is for next year because it's going to be repeated over and over and over and over. No matter how hard the question is, if you can just try to focus on the gradient of a straight line, it's all year 9 maths from there. Okay, the hardest step is here. That's what you need to know. So what do most students struggle in year 12? It's doing this. This is literally everything for year 12. Whatever I just wrote up here, this is your year 12 stuff. That's all it is. Chain rule, product rule, quotient rule, all the derivatives. And you spend like 2.5 weeks to do all that. It's the same things over and over. So don't forget the purpose. The how is easy, it's the purpose. Okay? Anyways, that concludes my lesson there, guys.